So last time we started with the hypothesis testing, and then I remember we did the example with the DMV, and then I remember telling you that when it comes to decisions, we have the statistical and then the English conclusions. And I remember I gave you a hint that anytime you have p-value less than alpha, we should reject. We reject what? The null hypothesis. And then if you reject the null hypothesis, what it means is that there is sufficient evidence. And then if you get a situation whereby the p-value is greater than the alpha, we fail to reject. And if you fail to reject, it means there is what? No evidence or insufficient evidence. I remember telling you that unless stated otherwise, usually alpha is 0.05. Unless they state otherwise, usually alpha is 0.05. And then I remember we also saw that in StatCrunch too. So that is how to do that. So for example, when you look at what we did last time, we had a p-value of 0.0019. So we have to decide whether we are going to reject or fail to reject. I remember telling you that there are only two things you can do. You can either reject or fail to reject. So how do you decide that? Remember what I told you. Let's write our p-value. Here, our p-value was 0.0019. What do we compare it to? We compare it to 0.05. Then you ask yourself, is this less than this? Yes or no? Is this less than that? If yes, what do? We reject the null hypothesis. Is that okay? So we reject H naught. If it's not, if it's greater than that, we fail to reject. And anytime we reject, it means there is what? Sufficient evidence. So you can look at the conclusion I made for the example we did last time. So since the p-value is small, we reject the null hypothesis. And then what it means is that then there is a strong evidence or there is enough evidence that the passing rate for teenagers taking a driving test is lower than 80%. To reinforce our understanding on the hypothesis testing for the proportion, let's open to StatCrunch and then try this example. So let's open to StatCrunch chapter 18 homework and let's do question 2. So remember, this should always be in your note. This is the guideline. You see, if we reject H naught, it means there is enough evidence. If we fail to reject H naught, then there is not enough evidence or there is no evidence. And to decide whether we reject or fail to reject, we have to check if the p-value is small, we reject. If the p-value is large, we fail to reject. Those are the basics, so you shouldn't get them wrong. So if the p-value is small, we reject. So if you get a situation where the p-value is small and you say we fail to reject, that is incorrect. So let's open to chapter 18 and then let's attempt question 2. We will do 2, 3, and then 10. So chapter 18, question 2. When you look at what I have on the screen, I believe everybody's own is different. So I'll go with mine. So you guys have to help me answer mine. So when you look at mine, it says that a very large study showed that aspirin reduced the rate of first heart attacks by 36%. It goes on to say that a pharmaceutical company thinks it has a drug that will be more effective than aspirin and plans to do a randomized clinical trial to test the new drug. So A says that is the alternative to the null hypothesis more naturally one-sided or two-sided? We learned whether it's one-sided or two-sided last time. It's only two-sided if the alternative has not equal to, and it's one-sided if it's either less than or greater than. So in this situation, is the alternative one-sided or two-sided, and why? Mm-hmm.
One-sided,
Why?
because they were trying to, get one a more effective drug, they wanted to be strictly better than.
Yeah, that is true. So when you read, it says that it thinks that a drug will be more effective. So it's just one-sided. Is that okay? And then it goes again to ask you to tell the new drug is because it's what? More effective. If it had been either more or less, it could have been what? Two-sided. That means it could be less or it could be more. Is that okay? But in this situation, it says that what? More effective. So only one-sided. And then let's get to B. So the B says that you have a p-value of 0.208. So a p-value of 0.28. So let's compare it to 0.05. Is the p-value small or big? We are comparing this p-value of 0.28 to 0.05. Is this 0.28 bigger than 0.05? Yes or no? Yes. So if it's bigger than that, it means that what? We will fail to reject, which means that what? There is not what? Enough evidence. Is that okay? So there is not sufficient evidence because the p-value is what? Large. And then we get to C. C says that if the p-value is 0.0028, is the p-value large or small? Small. So if it is small, it means that we are going to reject the null hypothesis, which means that there is what? Sufficient evidence. Is that okay? Because the p-value is what? Small. And then let's get to 3. So read 3 and then tell me what do you think the hypothesis is? Adam, what do you think?
Mine, not yours.
Okay. So for yours, what is the right answer?
It was H naught equals 0.16, and then P naught's 0.16. Someone for the signatures, it would have been D.
Okay, I see. Emma, what do you think is the hypothesis? I know most of you, I know your names. So when you look at this one here, it says that according to a recent census, 15% of the people in the US are of Hispanic origin. Okay. And then one county supervisor believes her county has a different proportion of Hispanic people than the nation as a whole. So she believes, or he believes, that her county has a different proportion of Hispanic people. So what does that mean? It means that when you look at the line carefully, it means that in her county, she thinks that the Hispanic people are not 15%. Is that okay? What it means is that it could be less than 15% or it could be more than 15%. Does that make sense? If it's one side, it's going to say maybe she believes that her county has more proportion of Hispanic people, then that is greater than, or less Hispanic people, then that is less than. But has a different proportion, it means that theirs is not 15%. Is that okay? Which means that it could be less than or more than. So when you look at that, it means that the alternative should be not equal to. Is that okay? Is that very clear? Good. So we get D. And then the B says that we should name the model and check appropriate condition for a hypothesis test. So what kind of test is this? So far, what have we been dealing with? We've been dealing with what? One proportion Z test. Is that okay? So not proportion T test. It's one proportion Z test. Is that okay? We've been dealing with what? One proportion, not two proportion. Two proportion means that P1 and P2. Is that okay? Good. So here is what? One proportion. And not difference in different tests. So you should just be careful on that. Good. So the next one says that we should check the appropriate condition for a hypothesis test. So all they are trying to do is for us to check the appropriate condition for the one proportion Z test. I remember we learned about this in chapter 16. And then I remember on Monday, we talked about it when we dealt with that example with the DMV. So you have to remember the four conditions. One, independence, randomization, less than 10% of the population, and then the failure or success condition. What a failure and success condition means is that n times p should be greater than 10, and then n times q should be greater than 10. That is the word success or failure condition. So that is what they are trying to ask you here. So for me, when I look at A, it says that the 407 residents were random sample from the county of interest. You can see which is true. And you can see, when you're faced with multiple choice, you have to be a bit smart. So you can see this first condition here runs through all of them. Is that okay? So we shouldn't focus on that. Let's get to the next line. The next line says the standard deviation of P is less than 0.5. Whenever we are dealing with the assumption, we don't care about the standard deviation of P. It's not part of the four conditions I listed. Is that okay? We also don't care about the sample size. We want the sample size to be large enough, but our main focus is that it should be what? Less than 10%. So we don't want a specific sample size. So you can see B is also out. Is that very clear? Then we get to C. So 407 is likely less than 10% of the population of a county, which is true. Is that okay? Now, so you can see this one is met, this one is also met. So all that we want to do is to check the success or failure condition. So we want to do n times p naught. What is our p naught here? In my case, the p naught is what? 0.15. Is that okay? So what is our n? When you read through the problem, n is what? 407. So let's try to multiply that. 407 times 0.15. So they say I should round to one decimal place. So I got 61.05. So that is 61.1. And then for you to get NQ naught, we learned already that Q naught is the same as what? 1 minus P naught. So 1 minus 0.15, which gives you 0.85 times 407. So that is, I got 345.95. So let's say 3446.0. Let me see. Yep. I got from 95, but they said to round to what? One decimal place. So if I round the 5 to 9, it gives me 346. Is that okay? Yours could be different, so you have to be able to check that. Now, here says that first the conditions are what? Are met. Is that okay? And when you read chapter 16, it says that when the conditions are met, we can use the what? The normal, it's appropriate to use the normal model. Is that okay? Good. That is the what? The Z stat we talked about last time. And then we check on that. Good. And then the C says that we should draw and then label a sketch and then calculate the test statistic and the p-value. So to do that, let's go to Start Crunch. We go to Stats. You see, this is about proportion. So we go to Proportion Stats. Is that okay? One sample. That is what we started so far. One sample, proportion stats. And then here we go to what? With summary. Is that okay? Stats, proportion stats, one sample with summary. We click on that. Now, the number of success. When I read the problem here, in my situation, it says that what they found that what 46 of those surveyed are of Hispanic origin. So the number of success is what? 46. So I put 46 here. Number of observation. What is the sample size? In my situation, it's 407. You have to put the hypothesis test properly. In my example here, I have P to be 0.15, and then the alternative is P not equal to 0.15. So I come here, I change this to 0.15, and the alternative is not equal to 0.15. Is that okay? You have to do it according to what you have. Is that okay? In my situation, this is what I have. And then, like I always tell, the significance level, which is alpha, is always 0.05. So you can see it's stated there. And then we hit compute. So when I hit compute, this sample prop is p hat. Is that okay? This sample proportion here is p hat. So p hat here is what? 0.113. Is that okay? This is the standard error. This is the Z stats. Is that okay? or the test statistic, and then this is the p-value. So when I come here, so we want to look at this. So when you look at the sketches here, now, what is our P naught? Our P naught here is what, 0.15. Is that okay? So you have to make sure that the middle of this curve here is 0.15. Is that okay? So when I look at that, it's only this that has the middle to be 0.15. You see, the middle is the peak. Is that okay? And then what is showing here is the p hat. So what's our p hat? 0.113. So you can see it's only this also has the p hat to be 0.113. And if this is 0.15, it means 0.113 is to the what? The left. Is that okay? And another thing you could also see is that look at this one, the p hat are incorrect. Here is 0.10, here is 0.15. That is not correct. Our p hat is what? Our p hat is what? 0.113. So you see. And then the middle here should be the p naught, not the p hat. So when you look at this one, you see they've tricked you. They've made the middle to be the p hat and they've done this one to be the p. Is that okay? The middle should be the p naught, which is the same as the p, which is what? 0.15. Is that okay? You click on that, you check. Now, we want to input the test statistic, which is the what? The z-stats. So z equals, what did I get here? I got negative 2.0892. So let me input that. So they want me to round to 2 decimal places, so minus 2.09. And then the p-value. What is my p-value? My p-value is what? 0.0367. You see, this is the p-value. The p-value is here. This, if they ask you for the what? The test statistic. The test statistic is what? The z-stats. You should always be careful. The test statistic is what? The z-stats. So I want to enter my p-value. So to 3 decimal places, I'm going to get 0.037. So then that is my answer. So, and then let's look at the conclusion. You have to ask yourself, when you compare this p-value here to 0.05, is this high or low? Low. Is that okay? So you can see if you're able to determine that comparing this to 0.05 is low, it means that A is out and then D is out. Is that okay? Because the p-value is what? Low, not high. So A is out and then D is out. And then whenever the p-value is low, what it means is that we are rejecting the null hypothesis. It implies is that then there is what? Sufficient evidence, or there is enough evidence. So when you look at this one, the p-value is so low, there is evidence, which makes sense, and then the p-value is so low, there's not enough evidence. Anytime the p-value is so low, there is what? Evidence. So we compare to this one and click that. Now let's get to question 10. So when you look at question 10, what do you think is the hypothesis? Okay. He thinks it's C. Anybody else? Okay, I have a question. What makes you think it's C?
Because it's saying that the rate in your question seemed to be higher than the 18% voted in. Your original proportion is 18%. So the new hypothesis would be higher than 18%.
Okay. Wesley, I have a question to you. Why is it not A? And then you think it's C? I think it's 0.3.
The B value.
Okay. So he answered it. So we learned that what the hypothesis, it's about the what? The population parameter. Is that okay? And so that is the what? The main proportion. So when you look at this one, the main proportion is what? 0.18, not the sample proportion. Is that okay? So that is why it is what? C. And like he said, you can see from here, you can get the alternative from here that the rates seem to be higher than what? 0.18. So you see this is what? Greater than. Okay? And it's 0.18 and not 0.30 because the hypothesis about the what? The population parameter. And so you can see the national average is what? 0.18. Is that okay? Good. So now, tell me which of the following conditions are met. Remember, we have what? 4 assumptions: independence, randomization, less than 10%, and then success or failure. Is that okay? So, do you know the easy one to do first? The easy one to do is a success or failure condition. Is that okay? So, because you have your P naught to be 0.18, all you have to do is multiply 0.18 times 110. Is that okay? That is a success condition. When you do that, what do you get? So 0.18 times 110. I got 19.8, right? Which is greater than 10. So we're good. The condition it says that what? It should be greater than 10. Now the failure condition. What is 1 minus 0.18? 1 minus 0.18 is 0.82. You need to multiply 0.82 times 110. That is 90.2. So we can see that this condition here is met. Is that okay? And now you can also see that the 10th condition is also met because when you have a forest, they just took 110 trees. You can see that, you can also clearly see that there are more than 110 trees. Is that okay? So you can see that this 110 is definitely going to be what? Less than what? The entire trees in that forest. So you can see this one is also met. Are we all okay? Good. And then you can also see that the independence condition is met because each tree is different. Is that okay? Do you think the randomization condition is also met? If yes, why? If no, why? Okay. So the randomization condition is going to be based on how they selected 110 trees. Is that okay? When you look at the problems we do, most of the time they tell you that it was randomly what? Selected. Is that okay? Does it say it here? It didn't say. Is that okay? So, no. Does that make sense? When you go to question 3, you'd see that the Hispanics, it says that they randomly selected that 407 or so. So that's it says. But in this situation, it didn't say how they got the 110 trees. Is that okay? So good. So I wouldn't want to check this one. Any questions so far? We are doing this example because I want you to understand this topic better. Is that okay? Good. And then now we want to determine the test statistic. Anytime you get here, all you have to do is start crunch, put in the numbers, just plug in, and you are good to go. So let's go to start crunch. So if you've done one already, you don't want to waste time, just go to edit. Is that okay? I go to edit and then I put in. So here is 33 out of 110. So here is 33. And then here is 110. And then P equals 0.18, and here is what greater than 0.18. So you see, I change this one to 0.18. I come here and I change this to be what? Greater than. Always make sure that what? Your hypothesis is inputted in start crunch correctly. Because if you don't do it correctly, it's going to affect the calculation of the p-value. Is that okay? So you see, I check in this nicely. And then I just click compute. So this is p hat, which is 0.3. And then what is the question asking me to do? The question wants the test statistic. The test statistic is always the Z stats. Is that okay? So in my situation, I have 3.275. And then they wanted to, is it negative or positive? Let me check. Positive, okay. 3.28 because they want to 2 decimal places. Okay. And then they want the p-value. The p-value to be to 3 decimal places. So now who can tell me what p-value? So they want to 3 decimal places. So what should I put in here? So if you can't see clearly, it's 0.30 and 5.001. Do you all agree to that? Good. The last one says that we want the 95% confidence interval. You don't have to worry, okay? So let's get to start crunch here. Don't go and, you have to save time. Don't go and input everything again like we did when we are doing for the confidence interval for the for the proportion. Just come to edit here, and then all you have to do is when you come to edit, all the information you put in, it's already there. Is that okay? Instead of clicking the hypothesis test, click confidence interval. Is that okay? And then you have to check. They want the what? The 95% confidence interval. So when you click on this, make sure here is what? 0.95. If they want the 99%, it should be 0.99. If they want the 98%, 0.98. Make sure it's always this. Is that okay? And then remember, here you don't have to worry because we want the first one. Is that okay? So that way. Are we all okay on that? Good. And then all we have to do is to click on this one. So this is the lower limit, this is the upper limit. So the lower limit, I have 0.2143 and then 0.3856. So when we get here, so they want the confidence, let me see, 3 decimal places. So 0.214 and then 0.386. What is the p-value? So if you want the p-value, we still come to edit. Instead of clicking on this, we click on this one here. Okay? And then hit compute. 0.00, 0.00, still 0.001, right? Oh, the p-value is, so now is this p-value small or big? Small, because we are comparing it to 0.05. I remember telling you that if you are confused with the decimals, multiply them by 100. Is that okay? If you multiply 0.05 by 100, you get 5%. Is that okay? You get 5. If you multiply this by 100, you get 0.1. So it's very clear that this is what? Small. So the p-value is what? Low. Is that okay? If the p-value is low, what do? We reject. So remember, low means reject. Is that okay? High means fail to what? Reject. So since the p-value is low, what do? We reject. Anytime we reject, it means there is what? Sufficient evidence. Is that okay? So if you get confused, just put in your mind, RS, if I reject sufficient evidence. There are some basis techniques you can just have them. So all strong evidence, same meaning. And then we can check our answer. So I chose these 3 problems to be able to, so that we could do them to help you understand the hypothesis testing for one proportion better. Okay, now let's proceed to our notes. So what you want to learn is how to just compute the p-value. We've learned how to do it using StatCrunch. If you have number of successes, if you don't have number of successes, you just have the z-stats, we can be able to compute the p-value as well by just going to normal, calculate, and then we use the standard normal to compute that p-value. So to be able to do that, you have to be able to ask yourself, is a test one-tailed or two-tailed? And that is going to help you determine. How do you decide if one-tailed or two-tailed? You just have to look at the alternative hypothesis. And then if the alternative hypothesis is either greater than or less than, then it's one-tailed. And if it's one-tailed, is it right-tailed? It's right-tailed if here is what? Greater than. And if it's left-tailed, if here is what? Less than. So if it's right-tailed, you go to the standard normal, put it mu to be 0, sigma to be 1, and then whatever z stat you have, put it in there, and then you can get the p-value for that. If it is less than, change here to be what? Less than, you get the z stats. If it's two-tailed, to read the p-value, we just have to take the absolute value of the z stat. So it doesn't matter what z stat you get. The absolute value of any negative number is what? Positive. So we get that just like we are doing this. Because it's two-tailed, we multiply here by what? 2. Is that okay? So that is how to get that. Today, what we want to do, remember, we've learned how to test hypothesis for what? Proportion. Is that okay? One sample proportion. Now I want to test hypothesis for the mean. Is that okay? It's going to be same approach. So we are going to learn how to do hypothesis testing for the mean. We'll do one hypothesis, do bootstrapping, and learn how to calculate p-values. So remember when we are learning in chapter 17, we learned the z and then the t. I remember telling you we use the t when the population standard deviation is not known. We went ahead to do 2 examples on that. Same idea here. So anytime you want to do hypothesis testing for the mean, you have to ask yourself, is the population standard deviation known? If it is known, we are going to use the z. If it is unknown, we are going to use the t. So I am going to start with the one sample t-test for the mean. T-test, so I'm going to assume that the population standard deviation is what? Unknown. Is that okay? So we always do this if the population standard deviation is unknown. On Friday, I'll provide the formula for if the population standard deviation is known, and that you use the z. If it's unknown, we use the t. when we are dealing with the confidence intervals, we learned how to get the intervals for both Z and then T. So if the population standard deviation is unknown, we are going to use the T test. And then the test statistic is giving us this. Is that okay? So you can either write it this way or that way. It's the same thing. We learn the standard error for the sample mean is giving us what? S over square root of what? N. We also learned in chapter 17 that for one sample mean, for the T distribution, the degree of freedom is always what? N minus 1. So we talked about this in chapter 17. So what I want us to do now is we are going to apply the same thing like we did for the proportion. So let's try to write the hypothesis for this. So I'll write the hypothesis for this, and then I'll go to another example, and then you write the hypothesis for that. So when I look at this example here, it says that a company has a set goal of developing a battery that lasts over 5 hours. That is 300 minutes of continuous use. Now, the first 12 batteries lasted, they put in those minutes here. And then is there any evidence that the company has met its goal? So to write a hypothesis for this, we have H naught, H1. And then because it's a hypothesis for the mean, we always do hypothesis testing for the what? Population parameters. So here is going to be mu. Here is also going to be mu, not X bar. Is that okay? X bar is sample mean. Hypothesis testing is for what? Population parameters, not sample statistic. Is that okay? So the difference between this and what we did in proportion, it was P. Here is the mean, so you have to use mu. Is that okay? Now, when you look at this, it says that what? The battery lasts over 5 hours. So that is their goal. So this is greater than 300 minutes. I am using 300 instead of the 5 hours because the sample I have here are all in minutes. Is that okay? And so here is going to be what? Does that make sense? So you can see from here that our mu naught is equal to what? 300. Because when you look at the formula here, we have mu naught here. Mu naught is always the value here. It's just like when we're dealing for the proportion, it's always the value here. Is that okay? Same thing. What I want you to do would do this fully on Friday. What I want you to do is to read this and tell me the hypothesis. So read this problem and then tell me what you think the hypothesis is. I also want to pass this information to you. So if you have assignments, quizzes, or tests that are past due, after some time, StatCrunch would assign 0. Is that okay? So make sure you don't have assignments, tests, or quizzes that are past due. If it's past due, it means it hasn't weighted it. After some time, it's going to assign 0, which is going to drop your average. Is that okay? So make sure you don't have that. So what is the alternative? Okay. Do you all agree for this one? How about the alternative? Why do you think it's less than 10? My question, why do you think it's less than 10? And then why is it not this one or that one? Yeah, so you can read from here is that what? If it's what? Shortchanging customers. If it's shortchanging you, it means it's giving you less than what you expect. If it's giving you more, you're going to keep quiet, isn't it? Yeah, so it's less than. So we've dealt with this one. On Friday, we are going to proceed with the other steps for these two examples. And then if we have enough time, we will do these examples too on StatCrunch, if we have enough time. So until then, I'll see you guys on Friday.